Lists of data classes. Recall our two composite data types that we have learned so far, lists and data classes. Lists allow us to represent many of the same kind of thing. Data classes allow us to represent one thing that has many different parts. We can access elements of a list in order sequentially, or a specific one by position. We can access fields of a data class by the name of the field. They are both data structures that are composed of simpler primitive types, and as we will soon see, they are even compatible with each other. In order to represent more complicated reality, we have to start nesting data structures inside of other data structures. A list of data classes is one of the most important ways to nest data structures because it can represent a large number of things. A comparable idea is a table of data, where each column is of the same type and each row represents a single instance. An individual row corresponds to a data class, whereas all the rows together represent the overall list. In the example shown here, we see a table on the left representing 4 pets, and code on the right also representing the same pets. Creating lists is done with the square brackets. Creating data classes is done by calling the constructor function. Creating a list of data classes works the same way, with the constructor calls being placed inside of the square brackets, separated by commas. The amount of white space inside of the square brackets and between the commas does not matter. Sometimes longer lists are placed on multiple lines to make it easier to read them, although that is not required. Accessing nested data can be quite confusing, but the same consistent rules apply that we have learned throughout. If you have a list of things, you can access specific elements using indexing. When you index a list of data classes, that means you get one data class out, and you can then access attributes of that element. In the code shown here, the first print indexes the first element of the list and looks at the entire instance. The second print indexes for the second instance and then accesses its radius field. Since we have a list of data classes, we can also iterate through the list. While inside the body of the iteration, we gain access to each instance, and therefore the specific fields of each data class instance. A question to ask yourself, though, is what type of value is stored in the iteration variable? Many folks will incorrectly answer a string or an integer because they are comfortable with those primitive types. However, the answer is the same as it was back when we were dealing with lists. The iteration variable's type is the element type of the list. If you have a list of data classes, then the iteration variable's type will be the type of the data class. In the example shown here, the zoo variable holds a list of animal data classes. When we iterate through the zoo with a for loop, we create a new variable named an animal. That iteration variable, an animal, will be of type animal, not a string representing the animal's name or its weight, but the entire animal is stored in that variable. The code shown here demonstrates how we can still apply the loop patterns we have seen so far. The only major difference to the sum pattern shown here is that we cannot use the aBook variable directly. The total price variable is an integer, while the aBook variable is a book instance. The addition operator is not compatible with those data types. Instead, we must specifically access the price field of a book and add that instead. By correctly accessing the right field, we can unpack the complex data structure and use its juicy goodness. Putting the for loop and attribute lookup inside of a function does not fundamentally change how everything works either. Here we have a getRedCircles function, which uses the filter pattern to only get the red circles from a list of circles. Note the parameter type and return type, which is a list of circles. Although there is a lot going on in this code, you have seen each concept before in some form. The only thing complicating matters is that we are putting them all together in one place.